Hey guys, I'm making a video here on how to solve equations that have a radical symbol in them. So let's start with something like this. 7x plus 4 equals 5. So we want to get rid of that square root symbol. So we're going to square both sides. Squared and square root cancel out, leaving 7x plus 4 equals 25. And then from here, it's just easy, subtracting 4. 7x equals 21, divide both sides by 7, and x is 3. Now, whenever you got an equation with a square root symbol in it, you should always go back and check and see if that answer actually satisfies the equation. So our original equation was 7x plus 4 equals 5. And substituting 3 into there, we got the square root of 7 times 3 plus 4, which is 21 plus 4, which is 25, which is equal to 5, and that's what we have here. Okay, so we've checked, it works, and we're good to go. Let's do the next one. We've got the sixth root of 3x minus 7 is equal to the sixth root of negative x plus 1. Now to get rid of the sixth root, we're going to take it to the sixth power. That's going to give us 3x minus 7 equals negative x plus 1. Let's add an x to both sides. Now we got 4x minus 7 equals 1. And add 7 to both sides. 4x equals 8. And so x is equal to 2. Okay, moving on. Getting slightly more complicated, we have this one. 7 cube root of 4 minus 12x equals negative 14. Okay, think of this as layers of an onion. We're going to peel away this 7, and that's going to give us the cube root of 4 minus 12x. And now we got to get rid of the cubed, so we're going to cube both sides. That's going to give us 4 minus 12x equals negative 8. Subtract 4 from both sides, and you get negative 12x equals negative 12. And so x is equal to 1. Plug that in and see if it works. Let's give that a try. Let's plug it in. So we have 7 cube root 4 minus 12x. So 7 times the cube root of 4 minus 12 times 1. 7 times the cube root of 4 minus 12. 7 times the cube root of negative 8, which is equal to 7 times negative 2, which is negative 14, which is what we had here. Okay, so we've checked. There's no extraneous solutions. We're good to go. Okay, moving right along. Let's go and do this next one. We have the square root of 3r plus 6 equals r plus 2. Now for this one, we want to get rid of the square root symbol, so we're going to square both sides. And when we do that, we have 3r plus 6 equals, and here you got to be careful. R plus 2 squared means r plus 2 times r plus 2. It does not equal r squared plus 4. So just make sure you don't make that mistake. We got to use FOIL here. So we have 3r plus 6 equals r times r is r squared. This gives us a 2r. This gives us another 2r. So we have 4r altogether, and this gives us a 4. Okay, now whenever you have an x squared or an r squared and an r in the same equation, you've got to set it equal to 0 and factor it. So we're subtracting 3r and 6 from both sides. When we do that, that cancels out, giving us 0. That's actually a good thing. When you're solving quadratics, you always want it to be equal to 0, because now we can factor it. There's no other way of solving these things besides factoring for quadratics. And that gives us two solutions. R is equal to negative 2, and R is equal to 1. Now we got to plug those into the equation and see if they work. Let's go down and give ourselves some more room. So our original equation was 3r plus 6 equals r plus 2. And the solutions are negative 2 and 1, the possible solutions. So we're going to test these and see if they work. So let's plug in negative 2 first. 3 times negative 2 plus 6 equals negative 2 plus 2. That's going to be negative 6 plus 6. That's going to be 0. And this is going to be 0. And this is going to be 0. And so this works. And so our first solution, negative 2, that's a winner. Now we're going to try the other solution, which is 1. So substituting 1 in place of r, that's going to give us 3 plus 6. That's going to give us square root of 9. That's going to give us, and that works. So in this case, both of them work. There are no extraneous solutions. Sometimes it'll be one that works and another one that doesn't work, but in this case, both happen to work. Okay, let's take a look at another one. We've got k is equal to the square root, so let's make that better, square root of 6k plus 39 minus 2. So for this one, we want to get rid of the square root sign, but if we square both sides right now, we'll end up with 6k plus 39 minus 4. It just gets really ugly. You don't want to go this route because it doesn't actually get rid of the square root. Okay, so let's go and do this properly. The very first step is, before you square both sides, you got to isolate the radical. So we want to isolate the radical. We want to get that by itself. So we're going to add 2, and we're going to add 2. That's going to give us k plus 2 is equal to the square root of 6k plus 39. Now we square both sides. When we do that, we got k squared plus 4k plus 4. And on this side, we got 6k plus 39. And now we're going to subtract 6k. And we're also going to subtract 39. Because again, whenever you have a k squared and a k in the same equation, you got to make it equal to 0. Okay, so factoring this, we got k plus 5 and k minus 7. And so our solutions are going to be k is equal to negative 5 and k is equal to 7. Now let's plug those in and see what happens. Let's go down, give ourselves some room. So our original equation was k is equal to 6k plus 39 minus 2. Let's plug in negative 5, see what happens. Negative 5 is equal to 6 times negative 5 plus 39. So is this true? Negative 30 plus 39. Let's go over here. I think my pencil is dead. Yeah, test it out. Let's actually just do this in our head. Negative 30 plus 39 is going to be 9. Square root of 9 is 3. 3 minus 2 is 1. 1 does not equal negative 5. So this solution, the first solution, negative 5, doesn't work. Try negative 7 on your own and see if it works. Okay, that's it. Keep on working through these, guys.